Kia ora guys, this video is the second one using the questions from the 2020 paper that I gave you out in class today. So this is also a merit question and I'm just redoing this one to make it easier for you to find. So we're given two complex numbers here and there's an easy way to do this question and then there's a really painful way to do it. Given that u is equal to this and v is equal to this, where p and q are both positive real constants, find arg of u over v. So the first thing that you should be doing with this question is sketching both of those complex numbers. So let's just do two bad graphs. Sorry about the dog noises. Right, u is p plus pi. So we saw in class today that there are some kind of questions that get much easier because of the particular values, and this is one of them. So if I've got p plus pi, that means that I've gone out p units and I've gone up p units. So that tells me straight away that here's my point here. Let's just whack in that point there. So there's u there. So I know that the arg of u is equal to, I'm going to work in radians to give you the radians practice, pi on 4. And if I look at v, I've got negative q plus qi. So I'm going out q to here and I'm going up q to here. Again, those two values are equal. Bad graph tonight, right? Sorry, I really should be using a ruler. Right, here's my ruler. Okay, so the argument here is where I join up from the origin to the point. That's what the argument of a number is. And I'm measuring this angle here. So the arg is the angle formed by the positive direction of the real axis and the line segment going from the origin up to the point. And you can see by inspection here that the argument of v is equal to 3 pi on 4 or 135 degrees. Next, remember that when I multiply complex numbers in polar form, that I add the arguments. So the arg of uv is equal to u arg u plus arg v. But when I'm dividing complex numbers and I've got u over v, the argument is equal to arg u minus arg v. That was the proof we did, was the proof of this one where we did the stuff with the trig identities. And this was the one that some of you did as an exercise at home. But you don't need to have done the proof. You just need to remember that when we multiply the moduli, but we add the arguments. And when we divide two complex numbers in polar form, I don't know what SS means. Divide the module, that doesn't have an acronym, just remember divide and subtract, okay? In here, we've basically finished the question. So arg of u over v is equal to pi on 4 minus 3 pi on 4, which gives me negative pi on 2, right? So that's the good way to do this question. Now, I am not going to go through and do the bad way to do this question, but if you're doing it with algebra, and you don't notice that you've got nice easy angles, then the question would start off like this. Let's figure out what u over v is. Well, this is the really, really inefficient way to go, right? So u over v is equal to p plus pi. They've put this in the schedule, which makes me think that lots of people probably did try to do it this way. So we can do that, and then we're going to times by the conjugate there, and we'll keep going like that. Now that's going to get pretty ugly. The other way, yeah, no, really, by far the best way to do it is what we've done here, where we remember that if I've got two complex numbers, one divided by the other, then I can easily find the arguments using this here. Okay, so that's all I'm going to do in this video. I will do the other three questions later on tonight.